Welcome to ePathshala. I am Dr. Shakila from Avinashilingam University speaking on food quality attributes. The quality of food products in conformity with consumer requirements is determined by sensory attributes, chemical composition, physical properties, and the level of microbiological and toxicological contaminants and shelf life, and by packaging and labeling. Another unique trait of food quality is the hierarchical and dynamic interrelation of almost all its attributes. For this reason, the investigation of interrelated effects should be remembered when formulating an evaluation system for food products. From the definition of quality, we understand that quality is an arbitrary term, a matter of convention, and it may therefore be considered as constant over a period only, and that beyond the absolute level of product characteristics, it is also dependent on the base values designated in specifications or norms. The variation of product characteristics determines the change in quality only if the specified base values and the conditions of their determination are unaltered. Quality is a measure of the degree of excellence or degree of acceptability by the consumer. By quality, one can differentiate the individual unit of a product from the other units and can determine the degree of acceptability of the individual unit by the consumer. The quality may also be defined in terms of end use and may vary depending upon consumers' perception and need. Quality is the combination of attributes or characteristics of a product that have a significance in determining the degree of acceptability of the product to the user. For industry, quality is a measure of purity, strength, flavor, color, size, maturity, workmanship, and condition, or any other distinctive attributes of the product. Evaluation is in fact a comparison with an etalon, which means the location of the parameters of the product along a multivariate standard scale or space. For the numerical description of food quality, evaluation methods with so-called quality indices have been introduced. These indices provide a framework for development of methods necessary for overall food evaluation, necessary both in quality control and product development. Food research has revealed new knowledge of the interdependency of chemical and physical properties whose synthesis and rational presentation is needed. The calculation of the overall quality index is based on normalization by a predetermined method of the attribute parameters obtained by measurement or scoring. The higher valuation given to a certain attribute of food quality prompts implementation of enhanced quality assurance systems by food companies voluntarily. Factors determining food quality. Product quality itself is multidimensional, and as a result, national level regulation aiming quality of food products takes on many dimensions or regimes. There is no definitive list of all attributes of quality because the importance of such characteristics varies across circumstances and among customers. Food manufacturers usually have two stated levels of quality for products marketed. One deals with the product's quality established as company policy to meet consumer needs, and the other deals with product quality in terms of meeting governmental regulations and laws. Branded products marketed by a company are matters requiring the most careful attention by company management. It is a general rule that company policy related to branded product quality is more rigid than that required to meet governmental regulations. Company policy statements generally include a statement demanding that all products marketed meet the laws and regulations of all federal, state, and local governments. Characteristics of quality. There are three types of the quality characteristics, namely sensory, hidden, and quantitative, by which quality of food can be judged, as shown in figure 1. So, the quality criteria for the consumers depend upon various attributes like appearance, texture, flavor, nutritive value, and safety. Sensory properties. The measurement of sensory properties and determination of the importance of these properties to consumer product acceptance represent major accomplishments in sensory evaluation. These achievements have been possible as a direct result of advances in sensory evaluation in the application of contemporary knowledge about the measurement of human behavior and in a more systematic and professional approach to testing. Man accepts food on the basis of certain characteristics that he defines and perceives with his senses. These attributes are described in terms of sensations and are sometimes referred to as qualitative or sensory qualities. They include perceptions of appearance factors such as color, size, shape, and physical aspects. Kinesthetic factors such as texture, viscosity, consistency, finger feel and mouthfeel, and flavor factors or sensations combining odor and taste. Appearance or color. This is more important than taste and odor. Color increases the attractiveness of the product. It is the prime factor which also determines flavor, texture, nutritive value, and wholesomeness. By the sense of sight, size, shape, and color of the food and other characteristics such as transparency, opaqueness, turbidity, dullness, and gloss could be perceived. Judgment of the ripening of the fruits is also by color. The strength of coffee and tea is also judged on the basis of the color of the beverage. Appearance is first important attribute in selection of food. Appearance of any food commodity can be judged by the eye. Appearance may be in terms of color, size, shape, uniformity, and absence of defects. The second important attribute for sensory evaluation of food is kinesthetic, that is, texture and consistency. 5 functions that should be considered in understanding human reactions to color in foods are listed below. First is the perception. Food selection or judgment of food quality would be extremely difficult if color discrimination were removed, even though size, texture, shape, and other cues were left intact. Motivation. Food color and the color of the environment in which the food is seen can significantly increase or decrease our desire or appetite for it. Emotion. Liking or disliking a food is conditioned by its color. Attractive foods are sought out as pleasure-giving, while unattractive foods are avoided. Learning. By the process of experience, we learn what color to expect and consider natural, and we predict rather precisely what properties a food or beverage will have from our memory of similar materials. Thinking. Our reaction to unusual properties or to new foods can be changed if they are explained to us. The human eye has a remarkably fine qualitative discrimination for color, but is not a quantitative instrument. Consequently, precise color measurement requires modern instruments. This need is felt particularly where food products are blended to a certain standard from raw materials that differ somewhat in their color properties, such as with tomato catsup. The effect of climate and time of harvesting have a marked influence on the color of the raw materials from which many processed foods are made. Texture. This is the overall assessment of the feeling by mouth and hand, or it is sense of touch by hand and mouth. Mouth feeling include lips, tongue, teeth, and ears. Texture can be defined as the properties of a foodstuff apprehended both by the eyes and by the skin and muscle senses in the mouth, embracing roughness, smoothness, graininess, and so forth. The texture of the mouth feel of liquid foods, especially those that behave as Newtonian fluids, is closely related to their viscosity. When the degree of gum solution sliminess was evaluated by a trained panel, mouthfeel ratings were correlated with viscosity. Objective instrumental methods are available for measurement of these attributes, which could be correlated to the consumer's preferences. Mouthfeel is a product's physical and chemical interaction in the mouth. It is a concept used in many areas related to the testing and evaluation of foodstuffs such as wine tasting and rheology. It is evaluated from initial perception on the palate to first bite through mastication to swallowing and aftertaste. In wine tasting, for example, mouthfeel is usually used with a modifier to the general sensation of the wine in the mouth. Some people, however, still use the traditional term texture. Mouthfeel is often related to the product's water activity, hard or crisp products having lower water activities and soft products having intermediate to high water activities. Product mastication. Cohesiveness refers to the degree to which the sample deforms before rupturing when biting with molars. Denseness refers to compactness of cross-section of the sample after biting completely with the molars. Dryness is the degree to which the sample feels dry in the mouth. Fracturability is the force with which the sample crumbles or cracks or shatters. It encompasses crumbliness, crispiness, crunchiness and brittleness. Graininess is the degree to which a sample contains small grainy particles. Gumminess shows the energy that is required for disintegrating a semi-solid food to a state ready for swallowing. Hardness indicates force required for deforming the product to a given distance, that is, force to compress between molars, bite through with incisors, compress between the tongue and palate. Heaviness indicating weight of the product perceived when first placed on the tongue. Moisture absorption shows the amount of saliva absorbed by the product. Moisture release indicates the amount of wetness or juiciness released from the sample. Mouth coating shows type and degree of coating in the mouth after mastication. Roughness indicates the degree of abrasiveness of the product surface perceived by the tongue. Slipperiness shows the degree to which the product slides over the tongue. Smoothness indicates absence of any particles, lumps, bumps, etc. in the product. Uniformity refers to the degree to which the sample is even throughout. Uniformity of chew shows the degree to which the chewing characteristics of the product are even throughout mastication. Uniformity of the bite indicates evenness of force through the bite. Viscosity shows force required for drawing a liquid from a spoon over the tongue. Wetness indicates amount of moisture perceived on the product's surface. Flavor. Flavor is a combination of taste, smell and aroma and feeling. In short, it is a combination of taste and aroma. Flavor embraces the senses of taste, smell and a composite sensation known as mouthfeel. Flavor is a most important sensory property of many food products. Flavor as an attribute of food, beverages and seasonings is defined as a sum of perceptions resulting from stimulation of sense ends that are grouped together at the entrance of the alimentary and respiratory tracts. For the purpose of practical sensory analysis, the term for impressions perceived via the chemical senses from a product in the mouth is restricted. Defined in this manner, flavor includes odor, the olfactory perception caused by volatile substances released from a product in the mouth via the posterior naves. Taste, gustatory perceptions caused by the soluble substances in the mouth, chemical feeling factors that stimulate nerve ends in the soft membranes of the buccal and nasal cavities. Taste is due to the sensation felt by the tongue. Taste is limited to sweet, sour, salty and bitter. The dimension of these can be measured chemically and can be related to the consumer's preferences. Compounds responsible for taste are generally non-volatile at room temperature. They interact only with taste receptors located in the taste buds of the tongue. Aroma substances are volatile compounds that are perceived by the odor receptor sites of the smell organ, the olfactory tissues of the nasal cavity. The concept of aroma substances, like the concept of taste substances, should be used loosely, since a compound might contribute to the typical odor or taste of one food, while in another food it might cause a faulty odor or taste, or both, resulting in an off flavor. Smell or odor is an important factor in flavor and can be estimated by gas chromatography and related to flavor acceptability. Aroma is due to stimulation of olfactory senses with volatile organic compounds. Aroma may be fragrant, acidic, burnt, pungent, enzymatic, spoilage. Aroma substances are volatile substances that are perceived by the odor receptor sites of the smell organ, the olfactory tissues of the nasal cavity. The concept of aroma substances, like the concept of taste substances, should be used loosely, since a compound might contribute to typical odor or taste of one food, while in another food it might cause a faulty odor or taste, or both, resulting in off flavor. Some of the hidden characteristics include the nutritive value and toxicity present in food, and these are included the quantitative characteristics such as the crop yield and finished product yield, which determine the food quality. The ratio of weight for raw material to the weight of the pre-packaged finished product is known as the shrinkage ratio. Higher the ratio, greater will be the unit cost. So, low shrinkage ratio is desirable. Methods for determining quality. Broadly, two methods are used for determination of the quality in food industry as shown below. Various methods used for the determination of quality in food industry include subjective and objective methods. Subjective methods. In this method, individual is required to give his opinion about qualitative and quantitative values. This method is also referred to as sensory method. It is by experience of the individual. Different subjective methods are used for estimation, like 9-point hedonic scale, triangular test or composite test. Objective methods. These are based on recognized standards, scientific tests to any sample of the product without regard to its previous history. They represent the modern idea in quality control because the human element has been excluded. This method is divided into three groups: physical methods, chemical and microscopic methods. Physical method is the quickest method used to measure size, color, consistency, headspace, drained weight and vacuum as shown below. The common physical tests which are used for products have been listed in the table. Chemical methods are standard food analysis methods. These are used for quantitative evaluation of nutritive value such as moisture, specific gravity, fat, oil, protein, carbohydrates, fiber, enzymes, vitamins and pH. And this is shown in this figure, the common chemical tests. Microscopic methods. These methods are excellent in quality control. It is used for the detection of contaminants in foods. So these methods prevent food from adulteration and contamination. Factors influencing the quality of food. There are mainly 4 factors which affect the quality of food and these are depicted and shown below. Generic factors. Selection of cultivars and rootstock. Not all varieties of fruits and vegetables are suited for processing purposes. The choice of proper cultivar is perhaps the most important single factor for the preparation of a quality product. Specific recommended cultivars for one area of the country or even within the state may not apply to another area. Although high visual quality is desirable for most processing methods, the composition of the fruit in relation to flavor, texture, color and nutritional value is of paramount importance. Pre-harvest factors. These include climate, which could be environmental, cultural and harvesting factors. Environmental factors such as temperature, showing the maturity, color, sugar and acidity. High temperature reduces the quality of citrus, radish, spinach, cauliflower and increase the quality of grapes, melon and tomatoes. Low temperature causes chilling and freezing injury. Light, which is essential for anthocyanin formation. Fruits exposed to light develop lighter weight, thinner peel, they lower the juice and acids and show higher TSS than shaded fruits. Wind bruising, scratching and corking scar on the fruits. Humidity reduces color and TSS, increases acidity in citrus, grapes and tomatoes, increases the quality of banana, lychee and pineapples. Cultural factors include nitrogen, with a high nitrogen reducing ascorbic acid content, TSS acid ratio and keeping quality, but increases vitamin B1, B2 and carotene, and deficiency reduces the fruit size. Phosphorus. High phosphorus decreases size, weight, vitamin C, and the deficiency causes poor appearance in fruit. Potassium increases size, weight and vitamin C. Deficiency causes uneven ripening. Calcium increases the firmness of many fruits like apple, mango and guava. Harvesting factors. Stage of maturity, ripeness and physiological age are important factors that affect the quality. Physiological maturity refers to the stage in the development of fruit and vegetables when maximum growth and maturation has occurred. It is usually associated with full ripening of the fruit. The physiologically mature stage is followed by senescence. Commercial maturity is the stage of the plant organ required by a market. Commercial maturity commonly bears little relation to physiological maturity and may occur at any stage during the development and senescence. As a conclusion, the overall quality refers to the technological, physical, chemical, microbiological, nutritional and sensory parameters to achieve a wholesome food. These quality factors depend on the specific attributes such as sensory properties based on flavor, color, aroma, taste, texture, quantitative properties like percentage of sugar, protein, fiber, etc., and hidden attributes like peroxides, free fatty acids, enzymes, etc. Though quality attributes are many, not all need to be considered for a particular product. It is important to determine how far it is important. Relatively, the factor is in relation to the total quality of the product. Hence, the quality attribute of a particular product is based on the composition of the product, expected deteriorative reactions, packaging used, shelf life required, and the type of consumer. Quality standardization systems have come into force for regulating the gamut of operations in food manufacture. Quality assurance systems will greatly benefit the farm productivity and value addition. The country has to move towards an increasing awareness of the need to deliver quality rather than the enforcement of quality. The most effective way of implementing quality in exports is to make the exporter himself responsible for quality and minimize inspection. In order to ensure the remunerative price to the farmers as well as to gain the confidence of the consumer, pulses should be graded systematically. Promotion of brand names could also be one of the major steps in this direction. It will improve our ability to consistently supply high quality products to our markets. By ensuring that the product matches not only to the technical specifications but also to the tangible and intangible values like color, form, package, delivery time, mode of transportation expected by them, quality is ensured. The consumer not only seeks basic benefits but they look out for added features such as that of the role of packaging, color and branding. If this aim can be achieved in the Indian food scenario, it will be in a very strong position as a competitor in overseas markets. Thank you.